Okay, what up everybody? This is Mr. Stan. Today we're talking about projectile motion, and we're going to see how we can solve for a lot of things in a problem like this just by looking at the making graphs for horizontal and vertical motion, and we make 3 graphs for each: position, velocity, and acceleration. Right, and we'll see how these how you can go from one to another, and how if you know one, you can find another. And you'll be surprised, hopefully, how much you can find just by using this method. So, let's use this problem as an example. Joe kicked a football. In the beginning, it had a vertical velocity of 30 meters per second and a horizontal of 18, right? So, horizontal velocity, the V is for velocity here, in both these middle graphs. The velocity was 18 in the beginning. So I'll put 18 here. And then vertical, it was 30. I'll put a 30 right here. And that's all the information the problem gives us. So is that enough to solve for anything else? The answer is absolutely. Okay, so what we know about projectile motions is that only gravity is affecting the velocity of the object. And gravity pulls things down. It doesn't affect the left or the right motion, and so the acceleration here horizontally will be 0. Right? And when you have an acceleration of 0, that means that the velocity doesn't change. So the velocity starts at 18. We'd expect that to be a flat line, right? Sorry, that got a little fuzzy. Right? The flat line means that the velocity didn't go up or go down, right? That's horizontally. Okay, so imagine if you watch the shadow of this football go across a field, that shadow would not be speeding up or slowing down. Okay, but in vertical, velocity is going to have a very different shape. So because gravity is pulling things down, it causes everything to accelerate. Right? In this class, we round it to -10. Right? In the real world, it's like -9.8. But basically that means that every second that goes by, the velocity is going to change by -10. So this velocity, the vertical velocity starts out at 30. It's going to become less and less until it gets to 0. And remember, what happens at 0 velocity? It's not that it's hit the ground, it's actually reached its highest point. Right? And then it's going to go down, and that's why we have a negative velocity right here. And it's going to speed up as it goes down. Right? So we can, just looking at the this vertical velocity graph, we can find out more, because we know that every second that goes by, the velocity will change by -10. So how long would it take to go from 30 to 0? In 1 second, it would go down to 20. Next second, it would go down to 10. At the 3rd second, it will go down to 0. Right, so this would be 3 seconds right here. Now, question, will it always be this number divided by 10, giving you the time in the middle here? And the answer is yes, as long as we're using meters per second, that would work out every time. Right, so even if this was like if this was like 12.5, then you would still divide by 10 to get the answer here. So that works even if these are not whole numbers. Okay, we also know that the time it takes to get to the top is going to be the time it takes to get to the bottom, right? Because the acceleration is the same the whole time, and so the time it takes to lose its speed is going to be the time it takes to gain the speed back. It's basically how it goes. All right, so this is going to be 6 seconds here, because that's double 3. All right. Now, let's think about the shape of the position graphs. Right? For the horizontal position, it's going to move at a constant velocity, and so that means we expect this graph to have the same slope the whole time, because slope tells you how fast or slow something's going. Right? But with the vertical velocity, it's going to be fast at first, so you have a steep line. It's going to get less and less steep here, and at 3 seconds, this should be flat, all right, just for a moment, and then it's going to go down again like that, all right? So that happens at 6 seconds. The last things we need to know are what is the maximum height here and what is the distance that this ball traveled before it hit the ground, right? And we can find those. Notice we found this was 6 seconds, so it was in the air for 6 seconds, which means we can put a 6 everywhere here because it's all the same. It's all the same motion, the same kick. We're just graphing different parts of it. But it was in the air for 6 seconds, so we put a 6 everywhere. All right. Next, the principle is that if you want to go from velocity to position, you use the area under the graph of the velocity graph, right? And the area under the graph tells you the displacement. Okay, so if we shade in the area between 0 and 3, right, and remember this reaches its highest point at 3 seconds, so right there, then that tells us how far it went vertically from 0 to wherever that is. Right, and so the area of this would just be the area of a triangle, which is 1/2 of base times height, which is 1/2 of 30 times 3, which is 45. So it gets 45 meters away from where it started vertically at the center point. Okay, what that tells you is the football went up 45 meters and came back down. We can do the same thing over here horizontally, right? Remember, the area under the velocity graph tells you what the displacement is, right? So horizontally, the displacement would just be the area of this rectangle, and this rectangle is base times height. It gives you the area, and that is equal to 18 times 6. Okay, so 18 times 6, and then that is equal to 108. And so horizontally it traveled 108 meters. All right, and wait till that gets in focus. It's not focusing very well. There we go. Okay, back in focus. All right, so just a couple things we want to show you. What if you're not told the velocity? What if you're told the distance first? You can go from information here down to information here. Like for instance, notice that the slope of this line equals the velocity, right? So if we didn't know it was 18 meters per second, but we knew that it traveled 108 meters in 6 seconds, then you'd find the slope of this line, which would be 108 divided by 6, right? And I'll just write that down. Slope is equal to 18. Okay, slope is equal to 18, and that is the velocity here, right? Or if you go the other way, the area of this is equal to 108, and that is the position. Okay, likewise here, you find the area, you find the displacement here. Let's say they could have given you the time that was in the air, right? And had you find the velocity, and that would also have been possible because you take the time that it was in the air, cut it in half, and that's where it reached its highest point, the time that it reached its highest point, and then you'd have to multiply that by 10 and you'd find its starting velocity, right? Okay, one more thing, ending velocity. This thing vertically would have come down the same speed but different directions, so you put a minus 30 right there. Okay, so now we have all the numbers filled out, and hopefully you have a better idea of how to do these.